asked thousands of times. Well, what's our first step in trying to simplify radicals, sir? Break it down. So what did you break it down to?
I broke it down to 36 times.
Which would be the, you should say the 36, square root of 36 times the square root of 100, right?
Yeah.
And then you did what?
And then I did just square root of 18 times 2.
Square root of 18 times the square root of 2. And then you did what?
And for 100 I did square root of 50 times square root of 2.
Square root of 50 times the square root of 2. And then you did what?
And the square root of 18.
Yep.
And the square root of 9 times the square root of 2.
Square root of 9 times the square root of 2.
And then I did the square root of 25 times the square root of 2.
Square root of 5 times the square root of 2. Now you probably should be, as you're going along here, once you get to the square roots that don't break down anymore, put a circle around them so you don't lose track of them. Now what?
And for 9 I did the square root of 3 times the square root of 32.
Perfect. And those get circled. And then
And then for square root of 25, I did square root of 5 times square root of 5.
so now we're down to the end, which means we have 4 square roots of 2, square root of 2, square root of 2, square root of 2, square root of 2. We have 2 square roots of 3 and 2 square roots of 5. And what's the deal? When they have pairs, they cross off to give you just a regular number. So these two give you a normal 2. These two cross off to give you a normal 2. Cross off to give you a normal 3. Cross off to give you a normal 5.
Oh, so minus.
No, normal times. That's my little dot for times. 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. Now, for those of you that don't maybe can see this here, I could have stopped almost right here, because once you get to a perfect square, you know, why break it down just to get to where you're going anyways? In other words, the square root of 36 is a normal 6, and the square root of 100 is a normal 10, and right there you get the 60 that you came up with down there. If, in fact, that works for you. If you struggle with math, you might have to do it all the way down to its little pair of bottoms there, but otherwise, Emma Price, 30? We don't have a 30. Nor do we have a 33.
We never have a 33.
True. 5 minutes is what percent of an hour? 2 different ways you could do this. Which way did you try, Emma Price?
I tried with 60 times what number is 90.
Well, let's just do the chart here. Okay, we're taking an hour and breaking it down. Okay, we're breaking down the percent to the in the hour there. In other words, we're taking some number plus some number, we're getting 100%. And 100% of an hour is, here's your minutes, here's your percents. 100% of an hour is 60 minutes, right? They want to know, they've cut that into 5. Okay, we don't know what percent that is. I mean, if you needed to, you could put 55 there to make up that other difference, but this is really what they want. What over 100 equals 5 over 60? And unfortunately, it doesn't work out evenly. That's why we didn't get a nice clean answer there. You have to kind of do it out here. This times this equals that times that. 60 times what number equals 500? And if you divide that all out, you actually get 50 divided by 6, and you end up with that 8 1/3. Now, you could have also written an equation for this. 5 minutes is what percent, we don't know, times an hour. Okay, but you have to know that an hour is 60 minutes. You can't work with 1 section hours, 1 section minutes. And when you do that, you get the same thing. You're gonna get 5 equals 60n. You're just gonna be dividing 5 by 60, which is the same thing we did here. You'll still get the change field there. You'll still get 8, whatever. Shabam. Alright, Sage?
What are the labels for the box on the side?
Well, this would be parts of an hour.
Wait, so,
This is part one, there's not really any label. This is total. This is one part plus another part. It doesn't really say whatever thing there. Swarsk,
What's number 1?
the answer?
Yeah.
Very good question. 240. Jackson.
I don't understand how to do number 1. Or and 2.
And what?
And 2. 1 and 2.
Again, this is these are all ratio proportion things. What are we comparing here? We got doctors that recommended, so then you have the ones that did not recommend, and you've got total. If 3 out of 4 doctors recommended it, that means 3 out of 4 total recommended it. That means 1 doctor wouldn't have recommended it, correct?
Oh, that's right.
60 doctors surveyed did not recommend the product. So that's what goes here. 60 did not recommend the product. How many doctors were surveyed? So we don't even need this part here right now. We need it at the beginning. So 1 over 4 equals 60 over what number? 1 times 60. 4 times 60 is, there were 240 doctors. And that's kind of the same for this one here. This is a percent. This is a markup or markdown thing, I believe, right? The salesperson, do they mark down the car when they sell it or mark it up? If they buy something, they have to tack on some extra stuff in order to make money. So you've got the original price plus the markup equals the final price. And this is your percent, and this is the actual. What's the original percent?
Yeah,
How much was it marked up?
40%.
So the final price is gonna be 140%. Now, is $4,000 how much the car originally cost, or how much it cost after the end, or how much it was marked up? It's under the original. And they wanna know what was the selling price, they wanna know this. So you don't need this to solve it anymore. You have 100 over 140 equals 4,000 over what number? And it might be easier to reduce this fraction. 10 over 14. 10 times what is 4,000? 400. So you have to multiply 14 by 400 to get your answer. And 14 times 400 is $5,600.
you should do it with the 40 also.
Well, you could find out what 40% of that is and then add the two together, because this is going to end up being $1,600. Then add those two to get that. You could, if that's, I was just trying to save you a small but very insignificant step, or a very significant step. Anybody not miss any on the pretest? Pressure. You too, Lucas?
No,
Which question?
how do you do, like, how do you know which one the question is asking for number 6, 7, 8? Well, I know.
Well.
the traffic.
Lucas asked a great question. How do you know what they're talking about? Well, right here. First of all, it says the area of a parallelogram, and then it gives you the letters of the parallelogram. A, B, C, D. A, B, C, D. That's what they want you to find for the first one. And if I were you, I would have the formula for a parallelogram. The area of a parallelogram is just base times height. And again, knowing that those have to form right angles, there's only one right angle here. So it's this line times that line, 12 times 12. For problem number 7, it said trapezoid A, B, C, E. Is that what that last one is? Yeah, F, A, B, C, E. So that means you've got, for that one, A, B, C, E. There's your trapezoid. That's the area for that one. And they tell you should have the formula for the area of a trapezoid, which is 1/2 base 1 plus base 2 times height. And then for the last one, it said triangle ADE. So triangle ADE is this one right here. That's the area they want you to find for that third one. And the formula for a triangle is 1/2 base times height. Strongly recommended that you jot them their formulas down for you. Price. Does it deal with these problems? What? I can. Absolutely. I would love to find the area. Okay, so I've got the area, 1/2. The two bases in the trapezoid are the two that are parallel, so what are the two parallel sides? 12 and what? 12 plus 22, let me make sure that's right. 22 down there, 12 up there, and then the height is again the line that's perpendicular to those two bases, so that has to be 12. So there's your formula. Doesn't matter which one you take half of first, but you do need to add these together first. 34 times 12 times 1/2. I would take half of 12 and get 6, and then 6 times 34 gives you the area of that, whatever it is, units squared, 204. Still over this one? Anybody over those 3 problems?
Yes.
Nathaniel?
What was the answer to problem number 8?
Well, it'd be probably half of what the answer to problem number 6 was. Half of 72 maybe? Was it? I gotta go look. Oh, it's 10, I'm sorry. It is 1/2 of base times height. 12 times 10 is 120, cut in half is 60 for the triangle. And then 12 times 12 for the parallelogram is 144.
For number 6, I
Yes.
got 156 inches.
When you multiply 12 times 12, again, the two things that form the right angle, here's the little key, here's your little right angle thing. So the two lines that form the right angle are this one and this one. 12 times 12.
Oh, that's it.
Just because they extend the line doesn't matter. You don't have to, you don't have to worry about that little piece there because it doesn't work. Ooh, and Kala.
I just have like for number 7, it doesn't is the height always going to be the dotted line?
Unless you see one of the sides form a square corner, because it could happen that your trapezoid looks like this. In which case they probably wouldn't give you a dash line. But if it so happens that that this line just forms a right corner to those, then you don't need a dash line. But generally speaking, yes, the dash line they give because they have to give you the height, and there are no other right angles in it. It's a good point. A very good point to be made there. Brandon Norman.
Can you do number 72?
Pass that check there, good. But I am getting older now. Notes to yourself on this one. Okay. The first thing you do is do the left-hand division, which means you take 1.2 and divide it by 2, you're going to get 0.6, correct? Now, a lot of people go wrong on the next part over here. Okay? What do I do with these 2 powers of 10, 10 to whatever exponents? Well, probably the easiest way to think about this is think about just moving this whole 10 to the negative 2 to the top. And what happens when you move something from the bottom to the top? The exponent changes signs. So then it's 5 to the 10 to the 5th plus 10 to the 2, you get 10 to the 7th. The other way we've talked about it is you take the top and subtract the bottom, but you gotta remember, you are now subtracting a negative number. So 5 minus a negative 2 gives you a positive 7. So that's gonna be the only sticking part for you, okay? If you had 3 as your answer, you actually added these two together and didn't subtract them. When you bring this to the top, it has to be subtracting that number. And then this is not the right answer because it's not in scientific notation, okay? This first number has to be between 1 and 10. It's a simple fix. You just move the decimal to the right one place and make it 6. You make this, when I moved it to the right, I made this one bigger. That means I have to balance it out by making that one smaller. So it's 10 times 6 to the 6th. Question on this one? No? Lucas Espanol?
Cause your number one.
Number 11. Ladies and gentlemen. Figure, no there it is. Yeah, I saw a couple people have this. Why do we need 2 unit multipliers there? Again, I'll beat this in your head till you get it here. Because of this. Okay, we're finding area of something. Area of something means you have 2 labels. You are starting off with 54 square feet. That means you have feet times feet. And you need 1 unit multiplier to cross off each of those labels. And where do those feet have to go when you cross them off? You know that both of them have to go down here because you have to cross off the top with the bottom. And I'm changing it into yards. What's my conversion from feet to yards? There are 3 feet in 1 yard. I do my little crossing out, feet cross off with feet. I'm left with yards squared, which is what I want. My numbers are 54 over 3 times 3. 3 times 3 is 9. So 54 divided by 9 happens to be 6. Little mumble, this whatever. Jeremy S. Force.
How do you do 15?
Really? You were stumped on number 15? What line is it here? Here'd be the notes to the south here. When you're given these complex equations, the first thing you have to do is simplify each side. And how do we simplify sides? We do that by adding like terms. What can I put together on this side?
4x and x.
I have 4 x's and I subtract an x, that means I'm only left with 3 x's. Now both sides are simplified. The next step is to try to get the letter x by itself. And what do I have to do to get that x by itself? Get rid of the 5 by doing the opposite. Remember, this is always the last thing you do. So now I end up with 3x equals 12. And divide by 3. Same thing we always do with equations. X is going to equal 4. Are we on to 16? Is that somebody's question? Nick, thank you.
Do we have to do 14 on the test?
Probably the same thing. Be an easy one to get right. Sage.
16.
I knew there was a 16 out here. What's your question on 16, Sage?
I don't know.
How do you think you should do it?
Cross multiply.
What's that?
Or-
Cross multiply, yes, that's what I would do. You could reduce these, it might get a little confusing if you do, so maybe this is just the best way. You wanna take this times this. 2.8 times x is going to equal 4 times 5.6. So 2.8x is going to equal 4 times 5.6 is, how about 22.4? Right? Did I do that right? Sure, just say that. Now I just need to Sage divide by 2.8. I'm actually gonna do this out. 2.8 divided into 22.4. Move the decimal over, move the decimal over. And I'm gonna guess 8 is the answer. 28 times 8 is, 22.4. So x equals 8. Some of you probably could do some shortcuts there. I mean, you might be able to look at this and say, oh, 2.8 is half of this. So you could say, okay, 1 and 2. Okay, and to go from 1 to 4, you multiply by 4. To go from multiply 2 by 4, you get 8. Some of you that works for, some of you go, Lucas?
Could you do,
Lots of different ways, by the way. to do
minus
this.
4, and then that answer you have 56 by whatever?
Probably, if that works for you. If you understand why that is, it could be. Lucas is saying, couldn't you just kind of work backwards and say, okay, 4, when you divide 2.8 by 4, you're asking 4 times what gives you that, which is probably going to be 0.7 or something like that, is it?
Yeah.
Right?
Yeah.
And then flip it around and go the other way on top. But lots of different ways. If you get it and you understand why you do it, it works for you, I'm good with that. Christ. Alright, there's a new one. Perfect. And again, you've got graph paper for this one. How do you graph y equals 1/2 x plus 1? You have stuff on your notes. The first thing you look for is the Jeremy Schwartz. Right, the y-intercept, which is that's where it crosses the y-axis, so you put a dot there. And then the second thing you look for is this 1/2, which we call the slope. And the slope is, top number is the how far up it goes, second number is the over number. And it's positive, so it's going to go up 1, over 2 this way, up 1, over 2 this way, up 1, over 2 this way. And then your line's going to end up looking like that. And the question they said, is it direct variation? For things to be direct variation, they have to be a straight line, and it has to go through the origin. Got to go through the middle. This did not go through the middle, so it is not direct variation. Wow, can't have many. Emma Haynes, we haven't heard from you today.
Could you please do 74?
We haven't done for yet? I am done for it. You've got that, and it says the factor. Factor means take out what you can from both terms. When we look at that, looking at numbers, do 2 and 3 have a common factor? They do not. You can't take a number out. Okay, so you got to look elsewhere. The first one has an x squared, the second one has an x. So what do they have in common? What can you take out? Just 1x. Okay, and then you have to do the reverse distributive property. Once you take that x out, what are you left with? Well, this one started out being 2 times x, but I took one of those x's out, so I'm left with a 2x. This one was 3 times x, and I took one of those x's away, so that means I'm just left with 3.
Well, I thought you talked to, I heard the way.
Doesn't hurt. We can go over it there. Lucas?
Did we get it wrong if we put 1x?
No. Although I just would prefer you didn't. So we will. Nikki Conlon.
Back to 17, I'm confused.
Back to 17.
How you got, like 7 for the x components.
Okay, the rule says this, Nikki Kala, if you look at when we talked about dividing scientific notation, it says divide the left-hand side and then subtract the exponents of the 10. Okay, what you have to remember is when I do that, I am taking 5 and I am subtracting a negative 2. And when you subtract the negative, that is like adding 2. Okay, otherwise I said it might be easier for you to think about just moving this 10 to the top and it becomes 10 to the positive 2 and then combining them. Either way, you just have to be careful when it comes to those negative exponents. Brandon Norman,
You do 18.
I would love to do 18. More than life itself. That's embarrassing. We're going to switch to green because I'm tired of this. First things first with the numbers. What's the numbers there? If I have 24 x cubed y to the negative 1 over 16 x squared y squared. What happens to my numbers? What can I reduce the numbers by, Brandon? Higher, how about 8? 8 goes into both of those, so if I divide them both by 8, I'm left with 3 over 2. Now, here's kind of, well, let's do the x's. They're both positive, so we're good with that. I have 3 x's on top, that's what x to the third power is, over 2 x's on the bottom. What's going to happen there? As long as I can cross them off one for one x goes away with 1x up there, a second x goes away with the second x up there, I am left with an x on top, because it didn't have something to cross off. Here's where you have to be careful. We don't deal with negative exponents, so I need to make that positive before I do anything with it. What do I do to make it positive? You have to move it to the bottom, it becomes y to the positive first power. And what happens when you have y to the second times y to the first? You get y to the third. And that's as much as you can do. You're left with the 3 and the x on top. You have to keep that exponent positive on bottom, so you end up with 2y to the third on the bottom. Jacksonian.
I don't understand number 10.
Is that on the other page or this one? Oh, I was surprised nobody asked me that question. This one, to me, is one of the harder questions on the test here. So Jackson, what's it say? A square, the sides of a square increased by a scale factor of 2. The area of the larger square is what percent the area of the smaller square? So, does it say how big to make the squares? Nope. So you get to choose. What are we going to make the dimensions of the first one?
Okay.
Alright, let's go with 2's. So if I have a second square that is increased by a scale factor of 2, how big are the sides of the second square? 4. Perfect. Now, we're talking about the areas of the square, so what are our areas? Area of the first square is, Jackson?
4.
4. Area of the second square is?
16.
16. And here's where I would draw the box, a percent box. And this is an increase in percent because it started out being an original thing. It increased how much to get you the final thing. Okay, the only thing we know about, probably the easiest thing to say is the original square was 100%. I don't know this or this, but I do know all their areas. I know the area of the original one was 4. The original of the final one, or the area of the final one is 16. That means it was an increase of 12. Now the question you need to figure out is, did they ask you what percent increase it was, or did they ask you what percent the final one was of the original one?
There's what percentage.
Right, it doesn't say what percent increase was, and you don't see the word increase in their question, so they're asking you for this. So when you do it, you don't really need this at all. You get 100 over what number equals 4 over 16. Is there an easy way to do that? Rockwell?
What you could do is figure out the line. I was gonna say 100, you get 4 times like 25 equals 100.
Sure, you could do that. I don't know if that's necessarily the easiest way, but you're gonna have to end up multiplying 16 times 25. And when you take 25 times 16, you indeed, in fact, will get 400 for your answer. Somebody was probably gonna tell me I could have reduced this, made it 1/4 as a fraction, and then 1 times 100 is 100, 4 times 100 is 400. Jackson.
I did 100. Can you do 100 times 16 and then divide it by?
You sure can. Yep, anytime you can't think about how to make it a simple one, yeah, cross multiply. 4 times this equals that times that. Lo and behold, where we at here? I see nobody asked about 5 and 12 and 13. 5, 12, 13.
45.
14 you won't have to do.
5.
Number 5, just for fun, since we're just about there. During the season, a basketball player made 24 out of 40 free throws. What was the probability that the player will make her next free throw? Well, probability is just the probability of a make. This is experimental because they actually did it, is how many total over how many you actually made. And how many total free throws did she shoot was the 40. How many did she make? 24. There's your probability, it just needs to be reduced. What goes into those? 8, 3 over 5. If they had asked you the probability she's going to miss it, that would be the one she missed on the total, which would be the opposite or the complement of that, as we say, 16 out of 40. There's really not too much to this one.
So you would just divide.
No, just leave the fraction.
No, I mean like the 40 and the 24 you would
You
divide.
subtract. Because you want to, if 24 out of 40, if she made 24 out of 40, that means she missed 16 out of 40. It's a subtraction. You're cutting them into those two pieces. What do you think, Jack? Gonna mail it tomorrow? Sage. I hope so. What was 13?
Formula for the following sequences.
Right. The only thing I'd write down is a little reminder for problem number 13. When we talk about sequences, the letter N is the number of the term you want. Okay. They gave you the formula. They said A sub n equals 2n minus 1, Sage. So any place that you see the letter n, you put in what term they said. And the term they said was 50th. Okay, so here you end up with this little a to the sub 50 equals 2 times 50 minus 1. So this just means the 50th term. That's what that letter is. So you just do this. What's 2 times 50? 100. And 100 minus 1 is 99. Can't I do the last one just for fun? What is it? That's question. Which one did we do? Oh, well, I don't know if it's 12. It's a little hard to see in my thing, but again, anytime they ask you for a net, that just means if you had a triangular box like this, and you took a pair of scissors and cut down the seams and tried to make it lay flat, what would it look like? Well, you know, if you cut it right up here at the peak and cut it right here on the triangle and here on the triangle, there on the triangle, there on the triangle, it's going to lay out. I'll do it three-dimensional here. You're going to have that bottom rectangle there with the two triangular pieces that make up this front piece and that back piece. And then you're going to have the two rectangles that form that come up and meet at the peak up there. You should have a triangular somewhere here. Should get to cut it all out. I would think you probably have that. That's not too terribly difficult of a thing. Jackson?
I did the triangles up and down.
That'd be fine. You can have your triangles here. Matter of fact, we should have a little contest to see how many different ways you can draw the nets of this. You could have a rectangle like this. You could have a triangle like this. Then you could have a rectangle shoot off like this. And you could have a rectangle shoot off like this. And you could have a triangle like this, I suppose. As long as you got two triangles that are connected with three rectangles in some fashion. You couldn't have a rectangle here though, that would just be odd or bizarre.